Welcome you guys to the DNS lecture. DNS is one of the most critical components on our local area networks and the internet today. If you don't have your DNS configured properly, your network slows to a crawl and the DNS won't work or your internet won't work at all. So it's really important to study hard when you're looking at your DNS and understand how it works. Okay, so spend a little extra time when you're studying DNS and really get it down. Okay, what does DNS stand for? DNS stands for Domain Name System or Domain Name Service. They're both used interchangeably out there in the real world. Okay, you can use it either way. Okay, both are correct. The definition of DNS, it's a network service that translates names into IP addresses. Okay, it's a real simple concept. Okay, you're sitting at your computer and you want to go to yahoo.com. Well, in order for your computer to connect to the yahoo.com web server, it must know the IP address of the web server. So what it does is it asks DNS, what's the IP address of yahoo.com's web server? DNS gives back the IP address. Once the computer has the IP address, it's able to connect to the web server and download the page. Okay? So remember the definition, a network service that translates names to IP addresses. Okay? Let's look at it more. Now, there's two different kinds of names when we're talking about names. There's host names, there's domain names, and then there's host names. Okay, now domain names are things like com, net, and org. Yahoo's a domain name. Google's a domain name. A lot of people don't know that yahoo.com, those are two separate domain names. Those are two different domain names. Okay? Here at Winter Park Tech, when we log into our computers, we put in a username, a password, and then we have another domain name down below. That's a Windows domain name, but it works the same in DNS. Timeout. Winter Park Tech is a domain name, so when you put in your username and your password, down below is the domain name also, and that's a Windows domain name, but it works the same with DNS. DNS is critical in Windows domains. Okay, so those are domain names. So when we talk DNS, that's part of our naming is domain names. Then we have host names. VWP RM 2026, that's actually a computer name of a computer out in the classroom. Okay, now in the DNS world, we're going to call it a host name, but it's really a computer name too. Okay, but when we're talking DNS, we're talking host names. Okay, the web server that serves up Yahoo.com's web page, maybe we call it Yahoo Web 1. That's the computer name, but in DNS we call it a host name. Maybe there's a domain controller here at our school, and it's called WPT Tech DC1. That's the computer name, but it's really a host name. Okay, maybe at home you've got a computer called Family PC or Bill's PC. Okay, that's the computer name, but in DNS that's our host name. Okay, so those are the two labels for names. So what are hosts? Okay, hosts are any workstation, printer, routers, servers on our network. In the DNS world, we call them hosts. Okay? Now, what do hosts have in common? All hosts have a computer name and an IP address. So that computer that's sitting out in the classroom here, VWP RM 2026, okay, that's the host name, but it also has an IP address assigned to it. Okay, so all hosts have IP addresses, and they have the host name.
Even the printers?
Absolutely. Absolutely. Web servers, mail servers, printers, any device on our network that's participating in a DNS network has a host, and it's had a host name and an IP address. So what's an IP address? An IP address is a 12-digit number broken up into 4 parts. And the IP address identifies the host. Just like the computer name, the host name identifies the host, so does the IP address. It's another way of identifying the host. Now, if you have 2 hosts, and they both have IP addresses, and they're exchanging data between themselves, they're more than likely using the TCP/IP protocol. Now, the TCP/IP protocol, there's 2 parts to it. The TCP part, Transmission Control Protocol, it stands for. That's the part that establishes and maintains an error-free connection between 2 hosts. Okay? And then there's the IP part of the protocol, which is the packet part of the protocol. It's the IP address, where one host has a packet. It packets its request, its IP address, and is able to send that packet down the Ethernet cable to the other host, and that unpacks it and can send it back again. So with the TCP/IP protocol, you have two hosts, and that's how they communicate, is with the TCP/IP protocol.
Using one IP address? Or?
They each have a unique IP address.
Oh, each has their own.
Each has their own unique IP address. So when we're talking DNS, what we're talking about is we're talking about hosts that have names and IP addresses, and these hosts communicate via TCP/IP. They do it whether they're communicating across the local area network or whether they're going across the internet cloud to a Bright House mail server or to a web server across the internet. You're going to see this internet cloud in white papers and lectures and in documentation. They talk about the internet cloud. That's the internet they're talking about. Okay, so those are the major components when we're talking DNS: the host name, the IP address, and TCP/IP. Okay, how do we find out, how do we look at the configuration of a host? And what I want to do is I'm going to walk over here to the computer, and I'm going to go ahead and minimize this. And there's a great Windows command called ipconfig, and it shows the configuration of the host. Okay, now the host here in this situation is going to be this laptop. This is a host. And if I type in ipconfig with the all switch, you'll see it brings up a lot of good information. Let's scroll down here to the top of it. Okay, one of the first things we see is the host name. So we know that this is definitely a host. It's got a host name. ipconfig shows the host name right away. Okay, it's got a lot of other good IP information that you're going to learn as you study Windows and TCP/IP. But the other one I wanted to point out is our IP address. The IP address of the host is also listed here. And then the last thing I'd like to point out that this host has is it has DNS servers. And there's the three IP addresses of the DNS servers. So when this host wants to go to yahoo.com, it asks one of these three DNS servers, hey, what's the IP address for the web server yahoo.com? And the DNS server does its research, sends back the IP address of the yahoo.com web server, and then this host is able to connect to the web server and download the web page.
Are you able to tell how many computers are on that network by when you do that ipconfig?
No, ipconfig doesn't do that. It just displays the IP configuration
Of just the one unit?
of the host. Yep,
The one host that you're looking at?
exactly. Okay. Oh. Okay, so let's do a little bit of surfing here and kind of demonstrate how this works. So what I'm going to do is bring up a browser. And we're going to type Yahoo. Let's go www.yahoo. Okay, and we've gone to the Yahoo web server and downloaded the web page. So what just happened here? This host, that workstation, this laptop here, went and asked the DNS server, what's the IP address for yahoo.com's web server? The DNS server went out and did its research and did its thing and gave the host the IP address. Once it had the IP address, it was able then to connect to the web server and download the web page. Okay, so that's what happened right there. Now, it just so happens I have the IP address of yahoo.com. I hope. Okay, so if we have the IP address of the yahoo.com web server, do I really need the name? No. Okay, and we can test that by just go ahead and typing in the IP address and go ahead and clicking on go. And you can see we go to the same page. Okay, but now we've used the IP address instead of the name. So in that situation, that laptop there, instead of going to DNS to find the IP address, the laptop already had the IP address. We typed it in. It went directly to the web server and then downloaded the page.
Mike, what about when you're at home, though, and you're not, most people don't have a network at home when they're logging into a domain?
Sure. What is your ISP, your internet service provider at home? Who do you have?
I think it's Bright House, I'm not sure.
Yeah, Bright House. Well, you know, you pay Bright House to connect to the internet. Well, a lot of people don't realize this, is that when you contract with Bright House for internet service, they're your internet service provider, they give you an IP address and they give you DNS servers. So when you're sitting at home and you type in yahoo.com, your computer goes and asks the Bright House DNS server, what's the IP address of Windows of yahoo.com? Gives back the IP address. Exactly. Yes? Sure.
I don't know if this is possible. Anybody who works in the White House here, but I remember with like for example, if you had an internet provider for like a phone company, you can have a static IP address for the DNS server. But for like White House, they use like I guess a dynamic where the DNS server will assign an IP address for you, assuming that they have multiple IP addresses you can use. Is there any way they can assign you a static address where you can type that address in and it will always be the same address?
Absolutely. You ask Bright House, and they will tell you what your static IP address is, but of course it's going to cost a lot more money because you can do a lot more on a network with a static IP address versus a dynamic. That's another whole subject that we'll get into down the road, is dynamic IP addresses and static IP addresses and all that kind of thing.
They'll charge you more money for using it.
Oh, yeah. Absolutely. Absolutely. Yep. Yep. Okay. So if we can use IP addresses and names interchangeably, it doesn't make any difference. Why do we use names? Very good. It's easy to remember. Names mean something, right? I mean, companies like Google and Yahoo spend millions of dollars in advertisements so we remember Google.com and Yahoo.com and Microsoft.com and eBay.com, right? So we remember those names, okay? And so it means a lot to us, and we know what these things do, and so that's why we use names and DNS to resolve our names to IP addresses. Now, on a Windows 2003 network, they rely heavily on DNS also. This is a Windows Explorer of my network at XOM. Here's my domain, XOM Inc., and here's some of my computers. We've got the ARL DC2. That stands for Arlington Domain Controller 2. Okay, that's a domain controller in Arlington, Virginia, right outside of Washington, D.C. Okay, we've got DAL DC2. That's a Dallas domain controller in Dallas, Texas. Okay, how about Orlando DC3, Orlando DC1? Okay, maybe over here, Orlando Windows Software Update Service. Okay, that's a Windows server that updates and patches all the workstations. Here's my mail server, ORL MS2. Imagine if that was all IP addresses. What a mess that would be, right? How would you know where you were or what you were talking to? And I've got a relatively small network I deal with. How about OCPS that has, Mr. V, thousands of computers? 33,000 computers. You imagine the lists of IP addresses the administrators would carry around if we couldn't use names? Okay, just by looking at the name, I can tell what the server does, where it goes. Okay, so DNS plays a big part in Windows 2000. We'll talk a little bit more about that. Now, how did I find out the IP address of the yahoo.com web server? Okay, one of the tools I used is a Windows command line command called ping. So I typed in ping, and I typed in www.yahoo.com. I hit enter. And what did ping do on the host? Ping went and asked the DNS server, what is the IP address for yahoo.com? DNS did its thing, replied back with the IP address of the web server for yahoo.com. Then ping went and sent a packet to that web server, and that web server then replied back again. Okay, ping's a great tool for testing, finding out an IP address. and it manages your network. You can test and see your communication between workstations, servers, and across the internet.
I use it a lot, especially when we're checking for internet connection
Yep.
on the customer's house.
Real quick, somebody has a hard time, you just ping something and boom, it replies back, and it's great. So ping is really a good one. Now, sure, go ahead, George.
Do you have to put a name, or can you use another IP address?
You could use an IP address, definitely. Yep, you could have typed in the IP address and you'd get the same reply back. Sure. Okay. Now, before I really talk about how DNS works, exactly how it works, I want to give you just a touch of history on where DNS all came from. Okay. The internet really started about 1969 with ARPANET. There were like 4 universities that got together and started exchanging data between their universities and their computers. And within just a couple years, between 69 and 1971, they added more computers, and this name and IP address thing started becoming a real problem. Okay, everybody had all these IP addresses, and nobody could keep track of who had what IP addresses, which computer. It was all just a bunch of numbers. And so they were already having this problem with IP addresses. So a lady by the name of Peggy Karp developed what was called the host lookup table. Basically, what the host lookup table is a small ASCII text file that she put on the computer. It's a notepad file, very small, and she put it on each one of her computers at the university. So when a host computer wanted to talk to the file server, you could type in a name, and then the host computer would then look at its text file. It's a little ASCII text file. It would resolve it to an IP address, and then it could use the IP address to connect it to the file server. Okay. It happened real quick because of the need for this, trying to remember all these IP addresses. Well, it took more than 10 years to actually develop the first domain name system, the first DNS system. Okay. Now imagine in those 10 years how the internet grew and the computers were added to the internet. We had hundreds, thousands of computers probably in those 10 years, and how confusing it was. Everybody's using IP addresses. It was just a mess. Okay? Another great thing about this host lookup table I forgot to tell you was when Peggy Karp added this little text file to everybody's computer, everybody could be using names, right? When she added a new computer to her network, what she had to do then is just update everybody's host file and just say, hey, we've got a new computer and here's the name of it. Everybody was fine. Okay, so she just had to update that. When she changed the IP address of a computer, she could just go and update that host file and then put it on everybody's computer, and everybody was fine again. That host file idea, within very short time, within 2 years, was completely used on the internet. Okay, it started out in '71 just being on Peggy Karp's university's computers, but then this idea was so popular that it was being used on all the computers across the internet. Remember, there's only 4 universities in '71, but by '85 there was a lot of computers, and they were all using this host lookup table. But imagine also that within 10 years, somebody'd add a computer to the network, update the host file, and then you have to send out the host file to everybody. Hey, everybody, update your host file. Well, with hundreds of computers and schools and businesses, all of a sudden it got to be a real mess. And that led or forced the evolution of the DNS system. Okay? Now, before we leave this, I want to show you the host lookup table. The host lookup table is still in existence today. Oh, and I was going to close this so I could browse to it. If you go to C, there's your C drive, and then go to Windows, go down to System 32, go down to the drivers folder, and then there's another folder called ETC. You can see right at the top, you'll see this little text file called hosts. You can see it's 1 KB, little tiny thing, little tiny file. Okay, if I open it up, I know I can do this. Okay, and I'm going to open it up with Notepad. Notepad is a pure ASCII text editor. Okay, and you can see it gives you some information about that host file. But let's do a demonstration here. Let's put in an IP address
and modify this file. And they will redirect you to, in other words, if you type in yahoo.com, you actually go to this, you go to an impersonating website. You have no idea because they went into your computer and modified your host file. So be aware that there are a number of viruses out there that are doing malicious modifying of this file, whereas Mike is actually demonstrating.
Okay. So what I've done is I've typed in an IP address and I put a name next to it. Okay. Now that IP address happens to be the IP address of Google. And so what I'll do is I'll bring up my browser and I will type in Billy Bob. Now let's go back to the file again. Now remember, I typed in the IP address of Google, and then I put it should resolve to Billy Bob. Billy Bob's a sharp guy. So if I put that in the browser, up there at the top, if we hit go, that should bring us to the google.com website. All right?
Now think about that. If I was a malicious virus writer and I went into your computer and instead of Sunbank going to this IP, I put in my Sunbank web server, and every time you go to www.sunbank.com, you don't go where you think you do.
Yeah.
You have no idea because this is a growing trend.
So if your computer looks at that before it goes to the
That's
DNS.
Exactly. Your computer looks at the host file, and this is still in use today. Remember Peggy Karp did it in 1971? 30 years later, this host file is still used by some administrators. Okay? But now with DNS really coming into being, you're not seeing it very much. But the client computer actually looks to the host file first to try to resolve a name to an IP address. If it's not in the host file, then it goes to the DNS server. Pardon me? Unix uses DNS? Absolutely.
No, I mean host file.
Oh, sure. Sure.
You have to save it first, right?
Oh, definitely. Definitely I saved it. Okay, so let's look at how DNS works. Okay? Now, DNS is a distributed database of names and IP addresses. Just like Peggy Karp took that host lookup table, that little ASCII text file, and passed it around to all the computers, that's what DNS is a distributed database of names and IP addresses. Okay, and it's distributed among all DNS servers. I did do that, didn't I? Okay, now this database is what's called a zone file. It's made up of zone files. Let's look at a zone file. Now this is a Windows 2003 server with the DNS services turned on, and this is the DNS console on a Windows 2003 server. Okay, and this actually is a DNS server on the ZOM network, on my network. Okay, now here's ParamountOnLakeEola.com. That's a zone. That's actually a zone. And each one of these lines is called a record. And altogether, it's called the zone file. Okay, all of this Paramount. Each one of these is a zone file. Like LakeEolaCondos.com, LandingAtBearCreek.com. Each one of those is a zone file on a DNS server. It's also domain. But this is a zone file now on a DNS server. Okay, so if you type in www.ParamountOnLakeEola.com, it's going to go to this IP address, which is the IP address of the web server. Okay, so let's try it. So I will type in www.ParamountOnLakeEola.com, and I'll click go. And we went to the ParamountOnLakeEola.com web server. So what happened in this situation? This laptop had a name. It went and asked the DNS server, I need the IP address of the www.ParamountOnLakeEola.com web server. The Winter Park Tech's DNS server then went over and asked my DNS server at XOM, hey, what's the IP address of your www record? And so it looked to that zone file and saw www. It saw the IP address. The DNS server gave it back to the Winter Park Tech DNS server. Winter Park Tech DNS server gave it to the host, the laptop, and it was able to go to the website then, directly to the web server.
So they went to like 3 locations before they even got to it?
That's correct. That's correct.
Okay? So now it just so happens, by sheer coincidence, I've remote controlled into the DNS server at XOM. Okay, this is the DNS server at XOM. It's a Windows 2003 standard server, and I click on Start, and one of the services that's turned on that comes with Windows 2003 is DNS. So I'm going to open up the DNS console. Okay, those are all my zones, all my zone files. And I can find Paramount on LakeEola.com. So if I type in mike.ParamountOnLakeEola.com, I should go to that IP address. Okay? Now that IP address just happens to be the IP address for Yahoo. So I'll type in Mike, and I've already got it in there. Thank you. And sure enough. Okay? So what this laptop computer did is it looked at the Winter Park Tech DNS server and says, I'm looking for the IP address of mike.ParamountOnLakeEola.com. It went and asked, the Winter Park Tech DNS server asked the XOM DNS server, what is the IP address for mike.ParamountOnLakeEola.com? It looked to its zone file, and it looked at all of the records, and sure enough, Mike was there, and Mike was associated with an IP address that just happened to be Yahoo.com's web server. That IP address came back to this laptop now and was able to connect to the Yahoo.com web server. See how powerful DNS is? It can do a lot of neat stuff.
Now, what if you had a rogue DNS server that injected itself into your network services? It could send you anywhere it wanted. This is why the security of your DNS server becomes real crucial, because if you get a rogue DNS server, and how difficult is it to bring a rogue DNS server in your environment? Just one laptop. And I can pop a rogue DNS server into your environment, and your users thought they were going.
Yeah. Windows 2003 certifications, when you're starting to become MCSA and MCSE and those things, they concentrate a lot on protecting your DNS servers and only allowing secure connections and all this stuff. So you'll get a lot of that as you study this. But this is why, how easy it is. Let's go ahead and add a record to this zone file. Okay, if I right-click, I'm going to click on New, and let's put in, I don't know, let's put in anything. Let's put in, how about Billy Joe? And then I'm going to put the IP address of, let's try Google this time. 216.239.51.99. 216.239.51.99. Okay, I'm going to add that. Say OK, and I'm done. So I've just added a record. Remember, a line is a record to the zone file. So if we go to Billy Joe, I minimize it, bring up the browser again here. Oh, here it is. Let's shoot over here and type in Billy Joe.
See what else?
Thank you. Exactly. Exactly. Okay, again, this laptop, a host, went to the DNS server and said, I'm looking for the IP address of billyjoe.paramontonlakeyola.com. That DNS server talked to my DNS server. My DNS server then looked at the zone file and found Billy Joe with the IP address, and then it gave back the IP address back to the Winter Park Tech DNS server and gave it to the host. That was pretty quick, too, wasn't it? Isaac?
From what you said about the zones, I thought within the zones were different, I guess, hosts.
Sure, that's right.
Isn't that right? So when I'm looking at when we're looking at the different zones in there, within every zone, is that not each different computer or printer or whatever it is? Is that what's in here?
Sure. Well, remember, we had a www, and the IP address pointed to a web server. And then we put Billy Joe, which pointed to Google's web server. And then we put Billy Bob, that pointed to Yahoo's web server. Okay? We could put other things in here, and I'll talk a little bit about this later. Things that point to file servers on the network, mail servers, so you can send email to people, FTP servers. DNS is used to resolve all these names to IP addresses. Let's keep going.
And as it looks, instead of an IP address, you can actually write the name if you want to also. Because I saw you had at the bottom yet is zominc.usa.com or whatever it was. Is that correct?
Well, Zom Inc. is the Windows domain name. Like you log in here to this network, you put in your username, your password, and WPT Tech is the Windows domain. Your computer actually looks to the Windows DNS server to resolve it so you can log into a domain controller. Does that make sense?
No, what I was asking was, like, instead of putting an IP address, can you put in, like, the name
Well,
of the actual
if
site?
you remember, Isaac, each record has the name of the computer and the IP. So every record you put in will include a name and an IP.
It'll probably be explained more, Isaac, as we get down here. Okay? Now, when we're talking about DNS, how DNS really works is it works in what's called levels. At the top of the DNS chain, we've got what are called root servers. Okay, root servers are designated by a dot. Okay, just a period. That's how you'll see, and you'll understand this more as we get to the next slide, actually. Okay, so root servers are designated by a dot, a period. Okay, then the next level down is going to be the top-level domain servers, the TLDs. Okay, now these domain servers, these DNS servers, if you will, are com, net, org, ed, us, biz. Okay, those are the top-level domain servers. Okay, and then the next level down is going to be our domain servers. Okay, like Paramount and Lake Eola. Okay, that's a domain server. Yahoo has a DNS server. Google. Okay, WPT Tech. Okay, those are domain servers. Now, one thing that's important to remember here, the root servers know where the top-level domain servers are. And the top-level domain servers know where the domain servers are, the first-level domain servers. Okay, so kind of keep that in mind as we're going through this. Okay, and we're going to get to forwarders in just a little bit. Now, to better understand this, I think we're going to look at I want you to look at the fully qualified domain name. Now, for instance, out in the classroom, we've got a workstation out there that's called VWP RM 2026, right? And we know that's part of the Winter Park Tech domain. And the Winter Park Tech domain, remember we said the COM servers know where the Winter Park Tech servers are? At the end of a fully qualified domain name, you're going to have the period or the dot, which represents the root servers, the top of the DNS chain. You're always going to see the dot. Many guys, when they're talking about fully qualified domain names, forget to put in the dot, but it's part of the fully qualified domain name. So the root servers know where the COM servers are. The COM servers know where the Winter Park Tech DNS servers are. And the Winter Park Tech DNS servers know all of its records, its zone file, right? Same thing with maybe the Winter Park Tech domain controller. Okay, another record, okay, and that's the fully qualified domain name. Okay, and it kind of shows the whole levels of the DNS chain. One other one I want to point out here is SMTP server. Okay, this is actually a fully qualified domain name of a mail server for Bright House. And we know that Bright House used to be called Roadrunner. So if we look at this, again, this fully qualified domain name has a dot, which is the root servers. We know the root servers know where the COM servers are. COM servers know where the RR servers are. RR probably stands for Roadrunner, okay? Maybe they could have put BH, but because it used to be called RR now, they just left it with RR. And then the Roadrunner is a domain level server, right? And then there's a second domain level server. Okay, this is the first level. This is the second level, CFL. CFL stands for
Central Florida.
Okay, Central Florida. And so the Central Florida domain then has the records for the mail server and the web server and their file servers probably. Okay? Yeah. Yeah, the SMTP server is part of the CFL domain. The CFL domain is part of the RR domain. And the Roadrunner domain is part of the COM domain. So you can work either way. Okay?
It's very important for you to understand the knowledge he is sharing with you is not optional. You must understand this. This is what today's networks are all about. If you don't understand this, you're in trouble. This is what it's all about. You must understand this stuff.
Okay? Yeah, Joe.
Are you going to get into the explanation of, for example, whenever you have a www, all knows World Wide Web, and this is basically for DNS servers or the World Wide Web, where if you're using like intranet, you wouldn't use the www. Are you going to get into that? Or?
Yeah, I'll talk a little bit about that. Yeah, absolutely. Okay, so let's look at what happens, how this actually works. Okay, so you're sitting at your workstation. This is the laptop here. And this laptop wants to go to www.yahoo.com. Okay, so what it does is it asks the DNS server, okay, I need the IP address for www.yahoo.com. Well, the first thing this DNS server does is looks to its zone file, its records. And of course, the DNS administrator here at Winter Park Tech did not type in www.yahoo.com and the IP address. So what this DNS server has to do is look to what's called, in the Windows 2003 DNS world, its root hints tab. Let me show you that. Okay, now this is the properties of a DNS server. Okay, so if the DNS server doesn't find a record, a name and an IP address that it's trying to resolve, it can go to its root hints tab. Now the root hints tab lists the root servers, the root DNS servers out on the internet. Okay, now there's 13 root servers, and these servers are designated by the alphabet, through the alphabet letters A through M. And you can see here's the G, the H, the I, the J, the K. Okay, they're not in alphabetical order, but the first letter really identifies the root server. Okay, you'll learn a little bit more about these root servers here in a minute. Let's go back here. So our workstation wants to go to www.yahoo.com. It asks the DNS server. It looks in its own file. It doesn't have yahoo.com. It looks at the root hints tab then, and it goes right to the top of the DNS chain. Now, remember we said that the root servers know where the COM, the net, the org servers are. And the COM and the net and the org servers, they know where the domain servers are. And the domain servers are like Ford.com and Yahoo.com's DNS server. So what the root server does in this case, when this DNS server asks the root server, I'm looking for the IP address of www.yahoo.com, it replies back, well, I don't know where Yahoo, www.yahoo is, but I do know where the .com servers are. So here's an IP address of the COM servers. So then the DNS server goes up and asks the COM servers. It says, I'm looking for www.yahoo.com. Well, the COM servers, remember, knows where the DNS servers are, the domain servers are, sorry. Okay? So this COM server then replies back with the IP address of the DNS server for yahoo.com. And of course, yahoo.com has all its records. One of the records is its web server, which is this one right here. So then this web server replies back to the DNS server with the IP address of the web server. It gives it to the client, and then the client, or the host, uses the TCP/IP protocol to go across the internet cloud, connect directly to the web server, and download the web page. Okay?
That is absolutely critical that you understand. how everything on their networks and their infrastructure is built.
Okay, there's some other little tricks in there we'll talk about here in a second. Okay, so there's the root hints tab on a Windows 2003 DNS server, and that's how it gets up to that root server. Okay, we'll talk more about that. Now I want to bring, and I think, George, this is what you were talking about a little bit. Okay, remember when I said that VWP RM 2026, that was a computer name out in the classroom? That was actually a host name of a workstation out there. And the fully qualified domain name was, or is, VWP RM 2026. It's part of the Winter Park Tech domain, which is part of the COM domain, and the root servers know where the COM domain is. Okay, so we know that that's actually a host name. Now let's look at www.yahoo.com. Remember in the case when we did Paramount on LakeEola.com, we had a www record that pointed to one IP address. Okay? And that IP address is actually the web server for Paramount on LakeEola.com. It serves up the web pages. But what DNS is real good about is it can do some what's called round robbing and IP address swapping and name swapping. So what this really is, this www, doesn't really point to a specific computer. What it points to is a whole group of web servers. Because, of course, Yahoo.com doesn't have just one web server that services everything. They've got hundreds, thousands scattered all over the world. So DNS, through some fancy things like we did with Billy, Bob, and Mike, can point the IP address to a group of web servers. And then through load balancing and round robin, it can sort it and send it to other web servers. So just remember here that not everything is a host name. This www is a label. Okay? Same thing with SMTP-server, the Roadrunner, the Bright House mail server. This more than likely is a label. It points to a group of mail servers. One individual computer, one individual box, and that's called a label. Yeah, George.
With the new Internet Explorer, you don't have to put www anymore for many of the websites. It'll directly, if you type in yahoo.com, it'll take you straight to Yahoo or and it works a lot with like.
That's all part of DNS.
It is part of DNS.
Yeah.
It's not because of IE.
Remember Paramount on LakeEola.com? Can I bring it up? Maybe I'll just bring it up real quick. Okay, let's bring this up again. See this one right here? It says same as parent. Well, same as parent means Paramount on LakeEola.com. So if I typed in http:// and then typed in without the W's, typed in Paramount on LakeEola.com, it resolves to same as parent, which is this, resolves to this IP address. And I've seen this DNS misconfiguration before. Sometimes you'll type in without the W's, and you won't get anywhere. You'll get page not found. Have you ever done that? You forgot to type the W's, and you went, oh, page not found, and you go, oh, I got to type the wwws on this one. They're missing this record in their DNS. Same thing. They put in the W's. They got the W's okay, and it resolves to the IP address, but they forgot to put in the same as parent, okay, which is same as Paramount on LakeEola.com. Okay, so that's what you're talking about. But it's a DNS misconfiguration if that doesn't come up.
Those are kind of like macros for in DNS kind of programming terms. The macros so the DNS can configure when you're looking up a website.
Remember, that's the DNS database. Remember the little ASCII text file with a name and an IP address? That's all DNS is. It's a little database that has names and IP addresses. And the DNS server looks to its database. Oh, www is this IP address, and gives up the IP address.
Same thing when you type something in and you can't find the address and it sends you to a search page. That's in the DNS as well.
Yeah, that's a little bit trickier thing. I think that has to do with the browser. The browser sees that you're going to get a page not found, and it redirects you to the Microsoft search page. Yeah, that's a browser issue. Yep. So, okay, so the other comment I wanted to make is this child and parent domain relationship. You're going to see this a lot in Windows 2003 domains and networks. Okay. This host is actually a child. That's not right. This host name is part of the Winter Park Tech domain. But the Winter Park Tech domain is actually a child domain of the COM domain. And the COM domain is a child domain to the dot, the root servers. Okay? And vice versa. The dot is a parent to COM, and COM is a parent to Winter Park Tech. Same thing up here. Okay? COM is a parent to RR. RR is a parent to CFL. And CFL has all the records for their hosts. Okay? And CFL is a child to RR, so it works both ways. So you're going to be seeing child-parent. Okay? And that's what they're talking about. This fully qualified domain name with the child and parent relationship. Okay? All right. So how do you get a domain name? Okay? Let's say Mr. Vanderpool wants to go buy a new domain name. Okay? He wants to go and sign up vanderpooluniversity.com. Okay? And he wants to set up a new web server. Okay, so he wants to set up vanderpooluniversity.com. So how does he do it? Well, remember we know that the .com servers know where the lower level domain servers are. Okay? So what he has to do is he has to go to the .com servers, which are called the top level domain providers. Okay? They're also called, some of them are called registrars. Not every top level domain provider is a registrar. But that's where Mr. Vanderpool can go, is to a registrar and register Vanderpool University. Okay? A couple of different registrars are Network Solutions, Netsol.com, and GoDaddy. Those are both top-level domain providers that are also registrars, and you can register domain names. Isaac? Pardon me? For a fee, absolutely. Hang on a second, yes.
Since I know it's kind of probably a little bit off subject, but since that's considered a school, wouldn't he have to go to an EDU? Would they still give him the .com even if he's considered a school under education?
No. No, you can register anything you'd like if it's available. Okay? So let me tell you how it works. Okay? So Mr. Vanderpool wants vanderpooluniversity.com. So he goes to, let's say he goes to GoDaddy.com. If you guys are going to do this, go to GoDaddy.com. They're less expensive. Okay? So he goes there, and he goes to the GoDaddy.com webpage, and the first thing he's going to do is find out if Vanderpool University is available. He types in Vanderpool University, clicks on search. It comes back and says, oh, yeah, nobody else has Vanderpool University. You can register. So he types in his name and his address, and he gives him his Visa card number, and he puts that in there, and they're going to charge him $8 a year to register their domain name. And now Mr. Vanderpool owns Vanderpool University, the domain Vanderpool University. And, of course, the top-level domain provider, the COM guys, know where he is, right? Know that Mr. Vanderpool owns it. So now Mr. Vanderpool wants a web server. So we know he's got to have a web server to set up a web page. He also has to set up a DNS server. So he's going to set up his DNS server. He's going to give his DNS server a name and an IP address. Then he's going to go back to GoDaddy.com, and he's going to log into his account, and he's going to say, hey, my main name server, and he's going to type in his name server, his main DNS server. He's going to type in his DNS server's name and the IP address, and he's going to click on Save. So now, anytime anybody asks the .com top-level domain providers where the records are, where the zone file is for Vanderpool University, .com, the top-level GoDaddy, is going to tell him his DNS server's right here. Here's his name and his IP address. You can go there. So then Mr. Vanderpool goes to his DNS server. He edits his zone file, puts www.vanderpooluniversity.com, the IP address of his web server right next to it. So anybody that wants to get to his web server now will go to the root server first, and then they go to the COM server. The COM server says, go to Mr. V's DNS server. The DNS server looks to its zone records, finds the IP address of the web server, sends that back. The host finally gets it and is able to pull up the web page. Okay, questions? That's a lot, you guys.
Are we able to make one of them with a virtual PC? DNS server?
Keep in mind, you can use any valid workstation, but you have to buy your domain name. You have to have usually a static IP, and you have to have servers to host your stuff.
It's got to be a
There you go.
it's got to be a public IP address. It's got to be a public IP address.
Create your own IP address? Come up with
Nope, you gotta go buy a static IP.
Mr. V has to give you an IP address for your DNS server, or your ISP. Your ISP has to give you your IP address.
GoDaddy, they'll host an IP address
They
for
won't
you. Like,
host
they'll
it.
give you
No, they're
file
just gonna
sharing.
let
They'll
you
give you
use a
anything you
name.
need, so you can have a website up at one of their servers.
Right,
And
right.
they're usually pretty good. I remember one of my friends bought a server back like 3 years ago, and he has had, I think it's 500 megs, and he paid one time. And that server has never gone down, and he uses it for file transferring. When his domain was down, his name, even though he couldn't look at his website, he can still use his file transfer back and forth. 'Cause all you gotta do is keep renewing your domain name, because that .com is like a
Yep.
public thing. You gotta be
Yep. GoDaddy and Network Solutions, they will host your DNS server. They will host your web page. And all you have to do is just post the web page. But this is what I want you guys to encourage you guys to do. Okay? Is I want you to do this at home. Okay? Let me tell you what I have at home. I have a computer I built. It's a Windows 2003 server, standard edition. It's a Pentium 1.8 gigahertz. Really not the fastest computer made today, right? It's got 768 megs of memory. And on that computer, I turned on the DNS services. Okay? Then I went to GoDaddy.com and I registered brokeneggs.net, and I said, anybody that's looking for brokeneggs.net has to go to my DNS server at home. Now, I had Bright House at the time, Roadrunner. And Roadrunner lets you use, and they're dynamic, they can change, but will let you use a public IP address that you can get to from anywhere in the world. Okay? So, you can go back to GoDaddy and put in the name of your computer and your IP address, and now everybody in the world that wants to go to brokeneggs.net will go to my simple Windows 2003 server sitting at home at my desk. Okay? I also took then and turned on IIS services, another feature that's part of Windows 2003 server, which is Internet Information Services, which is Microsoft's web server. And I made a web page and put it on there. Okay, so now when somebody's looking for the web server, it goes back to the same server and pulls up the web page. That Windows 2003 server is also my domain controller for my wife and my kids' computers. Okay, it's a domain controller. It does DHCP. It does NAT. It does, for studying and learning, you learn a ton. So I encourage you guys. Now, if you want to do this, okay, get with Mr. Vanderpool or myself, and we can talk about how you can do it. And there's resources here. Of course, you know, a lot of you guys are studying Windows 2003. There's a lot of a lot of information in the books you're studying, and there's a lot of things on the internet. But we'll help you do that. But I encourage you. You learn a ton. Okay.